Welcome to Dr. ACR Academy. Today we are going to study about acids, bases and salts, which is from CBSE-7-Sci-Chapter 5. Throughout the day, we use a large number of things like lemon, tamarind, common salt, oranges, curd and sugar, grapes and vinegar in our diet to provide energy with a delightful taste. But do they all have the same taste? For instance, curd, lemon juice, orange juice and vinegar taste sour due to the presence of acids, and gross chemical nature of the substance is called acidic. In brief, acids are substances which give a sour taste. The Latin word acer means sour, therefore the name acids. Now let us come to the baking soda. It does not taste sour, but it tastes bitter. Besides this, if you rub this solution between your fingers, we feel soapy. This kind of substances which are bitter in taste and feel soapy on touching are known as a base, and this nature of such substance is said to be a base. Basic. Next, let us observe some of the common acids we see in our daily life. Firstly, coming to an ant string has formic acid in it, and in tamarind, grapes and raw mango have tartaric acid in them. In amla, citric fruits, ascorbic acid or else vitamin C is present. In spinach, oxalic acid is present. In curd, lactic acid is present. And in oranges, lemon, citric acid is present. Finally, vinegar, and it has acetic acid in it. Now, we'll discuss about base which occur in our daily lives. In lime water, calcium hydroxide is present. In window cleaner, ammonium hydroxide is present. In soap, sodium hydroxide and potassium hydroxide are present. And in milk of magnesia, magnesium hydroxide is present. Coming to the next, can you taste these floor cleaners and toilet cleaners? No, right? So, a special type of substances called indicators are used to test whether the substance is acidic or basic. Indicators are a special type of substances that change the color when added to a solution containing an acid or a base. Indicators are of two types, namely natural indicators and chemical indicators. Turmeric, litmus and China rose petals are some of the naturally occurring indicators, and phenolphthalein is a chemical indicator. Now we'll observe some natural indicators around us. Let us start with litmus. Litmus is a natural dye commonly used natural indicator that is extracted from religions found only on meridian coasts. For lab purposes, litmus is available both in solution form as well as paper. The paper is available in red and blue colors. This is red litmus paper and this is blue litmus paper. Litmus has a purple color in distilled water. When added to an acidic solution, it turns red, and if added to a base, it becomes blue. To know the functionality of litmus paper, Put a drop of lemon juice on red litmus paper and put a drop on blue litmus paper with the help of a dropper. Now let us see the results. In the red litmus paper, it is red, and in the blue litmus paper, it is red. Both papers appear red. Why? What is the reason? Litmus turns red in the presence of acid. Turns blue in the presence of a base. Litmus turns red in the presence of acid. Turns blue in the presence of a base. When lemon juice placed on red litmus paper, as it is already red in color, we cannot see the change. And when placed on blue litmus paper, it turns into red. Before jumping into another topic, let us see what is a pH scale. pH scale measures how acidic or base a substance is. The pH scale ranges from 0 to 14. A pH of 7 is neutral. A pH of less than 7 is acidic. A pH greater than 7 is basic. Check what happens when these compounds are placed on red and blue litmus papers. First, we'll see what happens when we add anything from the basic block. And after that, we'll see what will happen if we add any acid to the litmus paper. First, when you add baking soda, which has pH of 9.5, we add it on red litmus paper and it turned to blue. And when added on blue litmus paper, it did not change its color because it was a base. And when lemon juice or vinegar was added, which had a pH of 2, when added on red litmus paper, it was red because it is an acid. And when added to a blue litmus paper, it was red. When we apply some logic here, we can understand the changes. A basic compound placed on red litmus paper, it changes to blue, and when it's placed on a blue litmus paper, it does not change its color because it is already in blue. The basic components like tap water, milk of magnesia, washing soda, lime water, baking soda, shampoo, soap solution and detergent. When any of these are added to red litmus paper, it will be blue. And when added on blue litmus paper, it will be blue because it is already in the blue color. Now we'll talk about acidic. When an acidic compound is placed on red litmus paper, no change, that it is already in red. When it is placed on a blue litmus paper, it changes its color to red. When we add a drop of vinegar or aerated drink on red litmus paper, red and blue litmus paper, the red litmus paper turns into red because it won't change color, but the blue litmus paper will turn red. Some substances like sugar solution and salt solution cannot change either the red litmus or blue litmus paper, so indicating these are neither acidic or basic, and these are called neutral substances. For these, this is a sugar and common salt. When added sugar solution or salt solution added on red and blue litmus paper, they won't change color as they are neutral substances. Now, time to predict the results. When we add a drop of any of these, what will happen to the red litmus and the blue litmus paper? Tell us down in the comment box below. Now coming to the next natural indicator, which is turmeric. Due to the similar color of the golden rod plant flowers, turmeric paper is also called the golden rod paper. This is the golden rod flowers. To use turmeric as an indicator, it has to be prepared as a turmeric paper. Turmeric paper is prepared by applying turmeric paste on blotting paper or filter paper, drying and cutting into pieces. The yellow turmeric paper remains yellow in acid and turns red in the presence of a base. Any substance that turns yellow turmeric paper into red tends to be a base, and which do not change its color remain to be an acid. Turmeric paper hands with baking soda solution, which were kept on our turmeric paper. After remove the hand, the paper turns into bright red because it is a base. The yellow turmeric paper remains yellow in acid and turns red in the presence of a base. When we add detergent to the yellow turmeric paper, the spots where the detergent has dropped, it will be bright red, as the detergent is a base. Now let's test few things on a turmeric paper. When we test lemon juice, it didn't change color as it is an acid. The color did not change, and same in the orange juice and in vinegar. And milk of magnesia, if we add a drop of milk of magnesia on turmeric paper, it turns bright red as it is a base. Same with baking soda and lime water. Sugar and salt did not change their color. China rose as a natural indicator. China rose is our next natural indicator. China rose indicator is prepared by dipping China rose petals in hot water until the water turns into red color. China rose indicator turns acidic solutions to dark pink or magenta color and basic solutions into green. And this is acidic solution called magenta, and this is basic solution which has green color. Now let's test some items which are the items which are used in our life daily. First we'll check shampoo. A drop of China rose indicator on shampoo, it turns green as it is a basic solution, and when added on lemon juice, it turned to magenta color, and same on aerated and soft drinks. And when we added China rose indicator to baking soda, it turned into green as it is a basic solution. When added on rice vinegar, any vinegar, it turned to magenta color, and it did not change color when added to sugar and salt. Let us analyze when these compounds mixed with all the three natural indicators. These are lab chemicals. First is hydrochloric acid, sulfuric acid, nitric acid, acetic acid, sodium hydroxide, ammonium hydroxide, and calcium hydroxide. This is the key. The results are hydrochloric acid turned red in litmus paper and did not change color in turmeric, and in China rose it was in magenta color. Coming to sulfuric acid, it turns red with litmus and does not with turmeric, and changes its color to magenta in China rose indicator. Next, coming to the next, nitric acid turns litmus paper to red and does not no change with turmeric, and turns magenta color in China rose indicator. And next, acetic acid turns red with at litmus and no change of color in turmeric, and turns magenta color in China rose indicator. Next, sodium hydroxide changes its color to blue in litmus and changes its color to red in turmeric and changes its color to green in China rose indicator. Next, ammonium hydroxide changes its color to blue in litmus and changes its color to red in turmeric and changes its color to green in China rose indicator. And next, calcium hydroxide turns blue in litmus, turns red in turmeric and turns green in China rose indicator. Now we'll come to acid rain. Before we get into another topic, it's worthy to know about the most harmful effect called the acid rain. Acid rain is a rain containing an overload of acids. The air pollutants like carbon dioxide, sulfur dioxide and nitrogen dioxide get dissolved in the air to form carbonic acid, sulfuric acid and nitric acid respectively. The air pollutants from the industries goes to the air and gets mixed with the clouds, and when the clouds are heavy, it is ready to rain. And when it rains, it has a lot of chemicals in them, so it rains acid. The harmful effects of acid on plants, animals, and historical monuments and buildings. It destroys the complete growth of the plant and kills animals. and changes the monuments colors and it changes the you can see the forms on the buildings. So far, we have seen what happens when an indicator mixes with either an acid or a base. By the way, let's see what happens when an acid is mixed with a base. Acid plus base is equal to what? Phenolphthalein is often used as an indicator in acid-basic mixing, which becomes colorless in acidic solution and pink in basic solutions. This is a phenolphthalein. It is colorless with acid. It is pink with base. The chemical behavior of phenolphthalein indicator can be understood by a small experiment. Take hydrochloric acid in a beaker and then add a drop of phenolphthalein indicator to it and mix it gently. And then dropwise add sodium hydroxide solution to it until it turns pink. Here, let's do some magic. Add a drop of hydrochloric acid and see the magic. It turns colorless again. Now again add a drop of sodium hydroxide solution to it. The result is turning into pink. In conclusion, phenolphthalein turns colorless in acidic solutions and turns pink in basic solutions. Based on this experiment, we can conclude that when a substitute amount of acid and base is mixed, each component destroys the original nature of the other and the resulting solution is neither acidic nor base. The property of cancelling the nature of the opposite components is called neutralization. The significant features of the neutralization are liberty of heat and the formation of new substance called salt. And the equation is acid plus base when mixed together gives us salt, water and heat. Acid, the equation is acid plus base is equal to salt plus water plus heat. Neutralization in daily life. In digestion and bite and land or soil preparation and industrial waste. Our stomach produces hydrochloric acid to digest the food, but in some conditions like overeating, eating fatty and spicy food, consuming too much of alcohol, caffeine, carbonated drinks and smoking may cause to secrete too much acid that leads to painful indigestion. Using antacids such as milk of magnesia, which has magnesium hydroxide and sodium bicarbonate, neutralizes the effect of excess acid and may help easy indigestion. In the few examples are antacid and eno and gasified. Gasified tannin have sodium bicarbonate and sodium carbonate, which are called as antacids. Here is a healthy, happy and strong man. Let us see what happens next. Ooh, an ant is coming and bit him. Next, coming to an ant bite. Ants inject a small amount of formic acid through its jaws as it bites and causes pain in the body. This pain comes due to formic acid. It can be neutralized by rubbing moist baking soda, sodium hydrogen carbonate, or calamine solution which contains zinc carbonate. Now we'll come to soil treatment. High quantity of fertilizers is being used in agriculture. This is the common practice. Even through chemical fertilizers help farmer to increase crop production, but their excess usage causes harmful effects to the crops. Additionally, they damage the soil by making either acidic or basic. Acidic soils. The acidic soils are neutralized by adding bases like quicklime, which has calcium oxide, or slaked lime, which has calcium hydroxide. These are acidic soils and they are not good for crops to grow on them, and it needs to be neutralized. Now we'll come to basic soils. On the contrary, the basic soils are neutralized by adding peat, elementary sulfur, aluminium sulfur, iron sulfur, acidifying nitrogen, and organic mulches. These are the highly basic soils. They need to be neutralized by adding acids to them. Now coming to the next, factory waste. Industrial waste is produced by industrial activities, which contains many acids. Generally, they are released into water bodies, where many aquatic organisms like fish are living there. The acids waste can kill the aquatic organisms. Here you can see dead fish due to acidic waste. So the factory waste are neutralized by adding basic substance before they get released into the water bodies